Hi everyone. Welcome to my DFT podcast, and I'm Kshitij Kulshrestha. And today we are going to discuss a very important topic in DFT design. I think you would have heard about different fault models what we use for DFT design. We have come across many fault models, like we have Stuckett fault model, then we have an edge speed fault model. You would have heard about bridging fault model. So many fault models are there. Okay, and with the help of these fault model, we do the different kind of fault simulations in our DFT task. So today we are going to discuss about a very important topic, which is very relevant, and it's a very popular fault model which we are using in VLSI design. In many of the designs, most of the customers are using this fault model. So we're just trying to, grab a little bit of deep insight of this fault model, and we will just try to discuss some minute intricacies associated with this fault model pertaining to the methodologies, the advantages, disadvantages, and those kind of things we're going to discuss. Okay, hope it will give you a deep insight, like where this particular fault model is going to be used, what are the methodology associated with that. Okay, so I'm not just going to take more much of your time. So today I'm going to introduce a very important guest. She's Priyanka Atre, and Priyanka, I'll just give this flows to you so that you can just introduce yourself.
Hi, Kshitij. Thank you. Thank you, everyone. Hello. So myself, Priyanka, and I'm working in an MNC for last 5-6 years. I have worked on so many projects in VLSI, working with the DFT industry, and so many tools we used. And the most important, we can say, the problem which we faced in at speed testings. And today we are going to discuss this topic. So we'll just continue with the topic.
Okay, so thanks a lot for your nice introduction. Okay, so now we will just we'll just go to this particular topic. So my first question would be, what is edge speed fault model and why we actually require it, okay, when we are doing the fault simulation. So can you just give a brief synopsis? What is edge speed fault model?
So I'll just share my screen and I'll explain you that what are the at speed testing and on which frequency we are using.
Okay.
So I'm sharing my screen. Are you able to see?
Not at the moment.
Kshitij, you disabled, host disabled attendee screen sharing. Can you please enable it?
It would be.
You just go to the settings.
Okay.
Because it would be better
Now
for
can you
better
check?
understanding. Okay, I'll just check. Yes, now I am able to see.
Okay. Are you sharing? Yeah. Now I
Yes,
can
I'm
see.
sharing. Are
Yes.
you able to see?
Yes. I can see.
Okay, so
Okay. So you just um, use this slide in the full view. Yeah. Thanks.
yeah. Okay, so as per the definition, you can see the term at speed testing is used when we use the functional clock frequency in the test. It means we all are from DFT background, so we know very well that what is the scan frequency and what is the functional frequency. I'm just briefing you with this diagram. This is our scan D flip-flop, where you can see we have four inputs, right? DI, SI, SC, and clock. DI is our data input, SI is scan input, SC is scan enable, clock, and scan output. So our output will be depend on the scan enable signal. So what will be the value of scan enable? If it is 0, then we are getting output D as a functional input. And whenever scan enable is 1, we are getting SI inputs. It means the value which we are keeping on scan input, we are getting it out. So generally, whenever we are doing this at speed testing, we are just taking the frequency which is on functional clock. So generally, whenever you are doing any at speed testing, we our focus should be on functional clock. So this is all about our at speed testing.
Okay, that's a nice description what you have given. But can you just highlight a little bit about the at speed fault model? When you are just trying to do the structural testing. Yeah, this slide I
Yeah,
think
yeah, yeah.
is going to explain about it.
Yes, yes.
Yeah.
There, as already Kshitij explained, there's so many fault models we are using for testing in DFT. But the most common fault models are stuck-at fault model and transition fault model. Stuck-at fault model, if any line is stuck on 0 or 1, then we are calling is at a stuck-at 0 or stuck-at 1 fault. It means if you are not getting output every time, you are getting some error in your output. And next is our transition fault. The fault caused by the rise and fall times are called transition delay fault. It means it will give you the output in the delayed form. So there are two classification, mean is slow to rise and slow to fall. It means you'll get the output, correct output, but it will take some time. It means your the value of the particular node is not rising from 0 to 1 or 1 to 0. So in this condition, you'll get the transition fault.
Okay, thanks
These
a
are
lot.
two famous.
Yeah.
Sure.
So we have understood, viewers, we have understood about why at speed testing is required, and we have understood the common difference, between the stuck at fault model and the transition fault model. So now I think my next question would be the at speed methodology. Yeah. So this is the right slide for us. And what I have heard, there are the two kind of methodologies what we have in our industry, and some customers would be using LOS, some customers would be using LOC, and sometimes a common approach we would be using, in which it could be a kind of an hybrid approach, in which we would be LOC and LOS both. So can you just elaborate a little bit more on the at speed methodology?
Yes, yes, correct, Satish. There are two methodologies which we are using for at speed testing. One is launch of shift, we called is at LOS, and second is launch of capture. Generally, we named as LOC. So generally, these terms are very common in DFT, LOS and LOC. So whenever we are talking about or in talking about LOS and LOC, it means we are talking about at speed testing. So I'll just try to brief. Firstly, we'll start with the launch of shift. So as per the definition, what definition says, the launch on shift, launching of data takes place at the last shift of the shift frequency. In this diagram, you can easily see there are two signals I have used in this this waveform. First is our clock signal, and second is our scan enable signal. Already I told that whenever scan enable signal is 1, we are getting the scan enable input, and whenever scan enable signal is going low, we are getting D output. So you can see, as per the definition, the launch is happening on the shift frequency and the capture is happening on the capture frequency. So that's why we are calling launch last shift of the shift frequency. Your launching will be happening on last shift frequency. So you can see there is a difference. You can see it is very difficult to change this scan enable clock from 1 to 0. So whenever we are seeing this 1 to 0 transition, it is taking time. So at that time, it is very difficult to manage this scan enable signal on at speed frequency. So what we'll do to overcome this signal, this problem, we are using some pipeline concept.
Oh,
What this
that's a
pipeline
very nice
concept will.
concept which you are, trying to explain. Because, when I was actually working with the launch of shift methodology, sometimes back, I think 5 or 6 years back in one particular design, I was having some issues with the launch of shift. So at that time, my team lead actually he asked me that, do you know the pipeline scan enable concept? So at the time, actually, I got to know a little bit about the pipeline concept. But this concept is pretty much important important for the launch of shift. And definitely, yeah, it's going to, give a deep insight, like what kind of problems we generally face when we are using launch of shift. Yeah, you can carry on.
Yes, so this pipeline concept, why we are introducing this concept, the thing is scan enable signal. You can see here from 1 to 0 transition, it is very fast because you are changing the frequency. You are coming, here we are coming, we are with shift frequency, and suddenly we want our scan enable signal to respond on the functional frequency. So it will be very difficult to manage. So what we'll do, we are just doing some exercise with the scan enable signals, because if you want this activity, it means your scan enable should be global for all the clocks on functional frequency. So we are just introducing the pipeline concept. What this concept will do, whenever your scan enable signal is coming, it will work as a low on shift. It will behave as a low frequency signal, and whenever when you want it on capture, it will come as a higher frequency signal. You can understand easily with this concept what this signal is doing. You are just controlling this scan enable and clock signal. Whenever your signal, this is simply a OR gate, so whatever you are keeping here, this signal will come out, and according to this will work. So only we are just playing with this OR gate, and this OR gate will decide what value we should fit here. So this is all about our pipeline concept. It means we are just getting that much time for the functional frequency.
No. Yeah, viewers, I just want to, just want you to give a small guideline here. So there are lots of papers, which are there in the IEEE, and you can just find out some patents also. And lots of research has been done actually. Pipeline scan enable signal, how to, how to analyze it further, and what kind of a strategy and tactics need to be adopted to, avoid this kind of discrepancy which we generally get when we are using the launch of shift because of the because of the scan enable dependency on the fast clock. So there are lots of papers IEEE. So I have actually found out a very good paper, and I'll just provide you a good description about that paper, and I'll just paste that link as well. So, okay, so that's a very good description what you have given on the launch of shift and what are the problems associated with it. And now I think it's time to move to the different concept that is called launch of capture, which is another speed methodology. Okay,
Yeah,
so you
yes,
can
it is.
just throw some
So
light on it.
one thing I would just want to mention for this pipeline concept, you just play with the value of scan enable 0 and 1, and you automatically you get to know that when it will be 0 and when it will be 1. So, okay, that's it from launch of shift. Next, we'll discuss the launch of capture. The launch of capture is a method in which we are using two pulses. One is for launching the data, and another one is capture the data. So what happens in this launch of capture method? No need to worry about the scan enable signal, because you're not launching data on the shift frequency. Both the things are on capture frequency. So there is no way to mismatch of your data, or your data should not be lost, because both the things, both the launch and capture is on same frequency. Sometimes you heard this word term also, broadside load. Broadside load, it means launch of capture only. This is another name. Some papers you can see this broadside load. It is nothing but your launch of capture. So this is all about launch and capture.
Okay.
And sometimes we use dead cycle also. Dead cycle is nothing but we are just giving some delay between launch and capture, so that our data should be properly launched and properly captured. So this
So
is all
that
about
cycle
our
is
launch
generally
of
called
capture.
as the padding cycle, what if I
Yeah,
remember
yes, yes,
correctly.
yes, yes,
Okay.
exactly. Exactly,
Mhm.
Kshitij.
Okay, so now we have
So it
understood,
is,
viewers, launch of shift, the problems associated with the launch of shift, like the pipeline scan enable concept you have to use, and we have understood the basic concepts about the launch of capture. Now, I think it's time to discuss a little bit in detail about what are the advantages and disadvantages associated with both kind of methodology. What are the pros and cons? So do you have something on these topics?
sure, sure, we'll
Okay.
discuss. So these are our pros and cons for launch of shift and launch of capture. In first line, you can see launch of shift is a full scan design. There are so many terms we used in DFT: full scan design, partial scan design. So what does it mean? Full scan design, it means every node, each and every node of your design is scannable. So launch of shift is a full scan design. So as I say that full scan design, it means your area will increase, because what you are doing, you are just changing every D flip flop with scan flop. You are just adding muxes, so area will increase. And full scan design, it means automatically your test coverage will increase. One pulse we are using in launch of shift, and patterns are less. So I'll just link this less test pattern concept with launch of capture. So what we are doing, launch of capture is a partial scan design, less test coverage. Same, I told you, whenever your device is fully scannable, it means coverage will increase. Partial scan, it means less test coverage you are getting. Next is 2 at speed pulses. We already explained that in launch of captured already. We have 2 pulses and more test patterns. Now the thing you are confusing with these two terms, that why less test patterns and why more test patterns. The reason behind is, whenever you are going to use 2 test pulses, it means you have to generate more patterns for testing this 2 cycles. So the test pattern count will increase. And the problem which we faced in launch of shift, this problem will not come in launch of capture of scan enable toggling. As I told, that scan enable toggling is very difficult, and we need to add some pipeline circuit. So that if you are going to add this pipeline circuit, it means extra area will increase, extra cost will increase, and again you need to test its this pipeline circuit also. So difficulty will increase. And in launch of capture, it is very easy to handle, because we are launching and capturing both the things on on functional frequency. So these all are our pros and cons. So every time we can't say that we are just using launch of shift or launch of capture. Every time it depends on your design requirement, what your design wants. So sometimes we need to use launch of shift, or sometimes you use to launch of capture. So every
Okay.
time it's a fight between both the things.
Mhm.
Which one
Okay,
should be best?
that's a nice description, and yeah, you have rightly mentioned like what are the pros and cons associated with it. So I just have a curious question, like presently, like in most of the industries or the customer, which particular methodology they are using, and why?
Yes, it is that what I'm saying, that it is really difficult to say launch of shift or launch of capture. Ultimately, it depends on your project. So right now, which the project which I am using, we are using launch of shift methodology. But in my previous projects, I use launch of capture. So it's a trade-off every time.
Okay, and can we
You
use
have
a
to
hybrid
face
approach
pros and
also?
cons.
LOS and LOC both can we use? Hybrid kind of a methodology can we use?
Yes, I heard about this hybrid approach, but till now, I don't have any hands-on on this.
Oh, okay. So viewers, we will just take a little bit more details in that. If hybrid approach, if we are going to use, if some customers are using, how they are using. So we'll just come back with some more advanced topic on this. So I hope, I think viewers, you like this podcast. So we have just covered a small topic like the at-speed fault modeling and the at-speed methodologies associated with it. So, and if you have any comments, you can just, shoot the comments to us. We'll just respond back to you. So thanks, Priyanka, for giving a very informative session. And definitely our viewers are going to benefit with that. We will come back with more interesting topic in the commencing future. So thanks a lot for your time.
Thank you, Shitesh, for the opportunity. Thank
All
you.
right. Thank you. Bye-bye.
Bye.